Hello guys, welcome to my YouTube channel AI with Hari. It's yet another day and yet another interesting topic. Today we are going to learn about Git internals, the working of SHA, commit, tree and blob. Let's get into the video. Git internals. Git actually stores the data in key value per, and also Git creates only in the form of object. Value is nothing other than the content of the file. SHA can be expanded as secure hash algorithm, which is designed to keep the data secured. Its main functionality is transforming the data into a hash encrypted value. Git uses a 40-digit unique hexadecimal value, where hexadecimal is a number format system which has a base 16. Also, it contains the number from 0 to 9 and the letters A to F. Generally, there are 4 types of Git objects available. The one is the blob, second one is tree, commit, and the final one is annotated tag. And in this video, we will learn about blob, tree, and commit. Generally, the commit object points to the tree and the tree object points to the blob. Now, let's move on to the practical implementation, where I'll have a folder named git internal and I'll open my command prompt over here. Initially, I'll make use of the command git init, which actually creates an empty git repository. Now, if you move to git folder, that is .git folder, we'll make use of a new command named tree/f, and you can see that there's an hook folder, info folder, but we will be much interested onto this object folder where our tree, blob and commit details goes on. As you can see that as of now there is an empty folder, right? Objects or info pack, it's being an empty folder. Now let's go back to git internals and we can type echo space hello, where hello is the content of the file, and you can make use of the symbol and the file name 1.txt. Now, if you execute the ls command, you can see that a file has been created at this point. Now, we can make use of git status command, and you can see that it is on the branch master, no commits has been made yet, and there is an untracked file named 1.txt. After executing git add command, if we go back to our .git folder and I'll make use of that tree command, you can see that in the object folder there has been an hashing file which has been created starting as 2a93d. When we executed git add, there has been an object created. What does a user see is actually add command do move the file from working directory to staging area, but git took the file, looked at the content, took that content of the file and put as a copy into the object directory called blob, which is a binary large object. Blob doesn't has a file name. Remember that blob creates only the hash file for the content. We can verify by using this command git cat -file, and you will make use of 2a93, which was the first letters of that object hash file, and we'll make use of /t. So you can see that it's a blob file. Similarly, when we make use of this print -p, the hello is being displayed, which is actually the content of the file. You have to make clear that blob does not store the file name, it stores only the content of the file. Now we will navigate back to git internals. After executing the git status, it shows that it is on the branch master, nothing to commit, and the working tree is clean. Now we will execute git commit. If we navigate to git folder and execute the tree command, and now you can see that there has been 2 more objects has been created. Now we can inspect these 2 newly created objects using git catfile command. Git catfile, and we will make use of that object 48, 54 and -type. T represents the type. After executing this command, it shows that it is of type tree, and by executing the same command as above and changing the -t to p, which means print, it shows a whole lot of a message, which is 100644 blob and 40-digit unique ID and also the file name 1.txt, where the 1 indicates that it is a regular file and the 00644 indicates that file permissions about read and write policies. So tree stores the detailed information about blob, its hashing ID and also the file name. So we got to know about tree and the working of blob. What about commit? For commit, we have another one object reference ID, that is command would be git cat file 3550, which is the first 4 digits, right? We are making this a first 4 digit and -t, which is the type. You can see that the particular ID belongs to the type commit. And similarly, if we execute a cat file 3550 and -p, which represents the print, you can see more detailed information the commit hashing contains. It contains the tree and its unique ID, author name, also committer name, also the date and time. So these are the things that the commit file contains. This is how SHA, tree, blob and commit works internally. It's mandatory that you do understand these, not necessarily you get into more depth, but you should know how Git internal working happens. As I said earlier, the commit points to the tree and the tree points to the blob. In commit, you could see that it contains the detailed information of tree and some other informations, and you can see that tree contains the detailed information about blob, where blob contains the detailed information about the content of the file. That's it. Hope it was informative. Share this video to your friends and subscribe. Thanks for watching. Happy day.